Because the Earth is a finite, matter has to be reused and recycled over and over again. So the atoms that are in you were once in the air, in soil, in water, in the rocks. These atoms had been also been used by the countless other living things, from dinosaur to plants to us humans. And after they leave you, they will become part of the other living things or of the environment. This recycle of matter is known as the nutrient cycle, and there are several different nutrient cycles for different elements. But today, we will focus on the nitrogen cycle, the process by which the element nitrogen moves around an ecosystem. The nitrogen cycle is crucial for all life on Earth because nitrogen is needed to make some of the most important molecules for life, including DNA, RNA, and proteins that are needed by all living things. Without nitrogen, there will be literally no life as we know it. So it is important to understand at least a little bit about how the nitrogen cycle works. Nitrogen gas N2 makes up about 78% of the atmosphere. You breathe it in and out all the time. In fact, we are doing it right now. The problem with N2 is that you can't use it to make any cold molecules. The three bonds between the nitrogen atoms and N2 makes it very hard to break apart. So you can't do any reaction to make DNA or RNA or proteins or anything else. The nitrogen atoms are essentially superglued together. Luckily, there are certain bacteria that can break the triple bond of nitrogen gas to make something that organism can use. These bacteria are called nitrogen fixing bacteria, and they are found in the soil and in root nodules of certain plants known as legumes, as well as few other places. These nitrogen fixing bacteria break nitrogen gas apart and add hydrogen atoms to it to form ammonia, NH3, or ammonium, NH4+. This process moves nitrogen from air to soil, and it's called nitrogen fixation because the nitrogen in the air is getting fixed, so there's living the things can use it. Ammonia can be taken up by plants and used to make important biological molecules like DNA and proteins, etc. This process of uptake and production of biological molecules is called assimilation. But not all the ammonia product produced by nitrogen fixation gets assimilated into plants. Too much ammonia can be toxic, and sometimes plants prefer to assimilate other nitrogen compounds called nitrates. So, our next step is the conservation of ammonia into nitrates, a process called nitrification. Nitrification is done by nitrifying bacteria. These bacteria oxidize or add oxygen to ammonia in chemical reaction that first convert the ammonia to nitrate, NO2 minus, and then nitrate, NO3 minus. Because oxygen is needed for this reaction, nitrification happens best in soils that are well aerated. Like ammonia, nitrate is plant fertilizer because it can be assimilated and used to make K biomolecules, DNA, RNA, proteins, etc. Once nitrogen is inside of plants and used to build our sweet biomolecules, it can pass the other living things through food webs. When an animal eats the plant, the nitrogen containing compounds in the plants move to the animal. When that animal gets eaten, nitrogen moves to other predator, and so on. Eventually, all things die and decompose. This returns to nitrogen back to the soil as ammonia in a process called ammonification. This ammonia can now be used again by plants or converted to nitrates by nitrification, and so nitrogen gets cycled around and around over and over again. Cycle. But we are still missing one key part of our cycle. So in order to have a complete cycle, nitrogen gas needs to get back into the air. So this is done by denitrifying bacteria and is called denitrification. During denitrification, bacteria convert nitrates NO3 minus into nitrogen gas N2. Denitrification happens best in low oxygen environment like waterlogged soils, and it reduces the fertility of the soil. So this is all one reason why it's harmful to our water plants.